Hello, and welcome back. In this lecture, we'll learn how to automate our current Docker workflow with Docker Compose. Currently, we have to start up the Redis container first, and then start up the app container and link it to the Redis container. This manual approach works well for small applications, but it would get rather impractical when the number of containers and the number of container links grow. What if our application have more than 20 components and they are all running inside containers? It would become very complicated to start and link all the containers. Here is where Docker Compose comes in handy. Docker Compose is a tool for defining and running multiple container Docker applications. So with Docker Compose, we can define all the containers in a single file called Docker Compose YAML file. We can run a single command to start up all the containers. Here is what the Docker Compose YAML file looks like. You can find this web page by Googling Docker Compose. If you installed Docker using the Docker toolbox, you should already have Docker Compose installed. If not, you can always follow the installation guide at this Docker Compose web page to install Docker Compose. You can verify if Docker Compose is already installed by running Docker Compose version command. See, it displays the current Docker Compose version. Now, it is time to write the Docker Compose YAML file for our application. Just create a docker-compose.yml file. There are two versions of the Compose file format. Version 1, which is the legacy format, which does not support volumes or networks, and version 2, which is the most up-to-date format and is the recommended format. To specify version 2, we just put a version column 2 entry at the root of the YAML. In this file, we define the services that make up our application. For each service, we provide instructions about how to build and run the container. In our application, we have two services, Docker App and RAIDs. First of all, let's work on the Docker App service. The first instruction we'll write is the build instruction, followed by column and dot. The build instruction defines the path to the Docker file which will be used to build the Docker App image. Because our Docker App Docker file is sitting at the same directory as this Docker Compose YAML file. Here we put dot, which means the current directory. The second instruction we'll write is the port instruction, which defines which ports on the container to expose to the external network. The port instruction is analogous to the -p argument of the Docker run command. Mapping ports are defined in host port column container port format. Here we just type port 5000 column port 5000 to expose container port 5000 to host port 5000. The next instruction is the volume instruction. A volume is a designated directory in a container, which is designated to persist data independent of the container's lifecycle. A typical use of volume is to share data between container and host machine. Volume instruction is defined in host directory, column, container directory format. Here, we bind mounting the app directory in the host machine to the app directory in the container. In this way, we can share the source code on the host machine with the container, so that we don't have to use the copy instruction to copy the source code from the host to the container in the Docker file anymore. And this allows us to make changes to the source code from the host machine and see the effect right away without rebuilding the image. Now, we're done with the Docker App service. Let's move on to the Redis service. The only instruction we need is the image instruction. The image instruction defines which image to run a container from. In this case, we use Redis image 3.2.0. As you see, we can either run a container from an existing image or we can build an image from a Docker file. All service would either need an image or build instruction. We're done with writing Docker Compose file. You might want to ask why we don't need to define the linking between Docker App Service and Redis. This is because the version 2 Docker Compose format supports Docker Network feature, which allows containers to be discovered by its name automatically. And any service can reach any other service at its service's name, so linking is not required anymore. However, if you're using the version 1 Docker Compose supports, you do need to add container linking here. Before starting up our containers, we can remove the copy instruction from the Docker file because we already have defined the volume instruction in the Docker Compose file to share the app folder between the container and the host. Now it's time to run our application. To run the app, we simply use the command docker compose up. The up command will build the images for all services defined in the YAML file, create and start all the containers. We can run docker ps to verify the Docker app container and the Redis container are up running. Let's summarize. We have demonstrated how to automate our Docker workflow with Docker Compose command. Docker Compose is a very handy tool to quickly get Docker environment up and running. It uses YAML files to store the configuration of all the containers, which removes the burden to maintain our scripts for Docker orchestration, such as starting, linking, and stopping our containers. In the next lecture, we'll learn more about Docker Compose workflow. That's it for this lecture. I'll see you later.